And we are continuing with Java 1. I like with our intro video, this VHS sound. I haven't heard it for quite a while, and it's something from childhood. This like the sound of VHS cassette being brought into the tape. So yeah, that's nice. Join me in the chat, guys. I love this interaction with us. I love that you writing your messages. In online worlds, it's really important to see the audience, to see this interaction. So thank you very much. Thank you very much for being active in the chat. So we are right on time, which I'm really glad of. And please let me welcome the stage the speaker. You haven't seen her yet, for sure. So Tanya, welcome back to Javon. Yeah.
Thank you. Thank you very
And
much.
guys, this is another thing which I want to share with you. It's like it's 5 years of this conference, so finally I can share some facts from back. So as I mentioned already, we have a quite a huge org team. You saw their faces, and it's really hard to me each year to ask them to join me here on the stage. They are really incredible people. They are genius. They are genius in preparing conference. They are very talented, but they are all shy, and that's a problem. I try to bring them here, and finally we have a talk from Tanya. The more amazing would be if I will prepare a talk on Javon.
Yep. Looking forward to seeing it at least on the 10th anniversary.
we need to make someone host in this case. So someone should host. So Tanya, please think of that. So next year you would host Javon conference, and I
Let's
will
switch
make a
the
talk.
roles. Yeah.
Yeah, let's make it happen. So coming back to, I love this atmosphere on this conference this year. It's really fun. So Tanya, speaking about your talk, what would it be about?
Actually, today I will continue my role of Java historian and possibly even Java archaeologist. So first, I would like, so before the presentation, since we have this great small talk, great opportunity for me to actually give some credits to the guys from our organizational team, and in general, for the ones who have inspired me to this talk, I would like to say special thanks to the Genius podcast, the Genius talk, in case if someone knows that specific content from EPAMers for EPAMers, because especially for Maxim Daderkin as one of the guys who have shared this inspiring story about the Jap, which was kind of long going in the language with a lot of its like controversial movement around applying, candidating, and all of that stuff. So actually, that's kind of interesting. So it become interesting for me to understand what exactly can be brought to the language by removal of something from it. And my presentation will be about the facts about the particular technologies which has been removed from the language, but not in the area of how we could replace them and whether they are actively used, but which lessons we can learn from this in terms of why this happened and how we should actually maintain the key principles of the language when we do something similar with our legacy code.
Yeah, no, sounds great. Sounds great. So let's jump into your talk. Before that, let me remind our audience that we have two chats. One on the We Are Community platform, another one on the YouTube. I will monitor both of them to announce your questions to Tanya in the end of the talk. So please use this opportunity to share your questions and ask them. And also feel free to share your emotions, your thoughts during the talk. That's also very interesting. And today, in this talk, we will speak about a lot of historical things. So I think, guys, that's really a place for you to share. All the conferences place for you to share your emotions. So use this
And cool
opportunity.
stories.
And cool stories for sure. So so let's dive into the topic. Tanya, good luck, and let's go.
Thank you. Thank you very much. So, yep. Let me remind you guys that my talk's name is Java's Forgotten Future, and I have the additional name for it on the slide, The Paradox of Progress Through Subtraction. This is exactly what I've already mentioned during the small talk with Roman. So basically today we will consider how exactly the language can move forward by like removing everything which is not necessary actually in the language. And I do not like actually this slide in terms of I do not like to tell a lot about myself. So as Roman has mentioned, we are too shy. We are just humble operatives. Who am I? I am Tatsiana Baraukova. I am software engineering team leader at EPAM, Java and cloud enthusiast. I really love computer games and some funny stuff in sci-fi, sci-fi movies. So today I will play a role of the real time and space machine for you in explaining some interesting facts and outcomes from them in terms of the Java language history. So let's begin as the real programmers from the chapter 0, from the problem statement. So, in general, that's an interesting fact that the Java language, with its principle write once, run anywhere, actually uses this principle not just across different platforms, but also across time. And actually, the language develops smoothly in terms of the backwards compatibility, and we can even run the code, at least partially, the code which was created for the Java 1.2, for example, on GVM for the GDK 25, and it might even work properly. So basically, this good movement and attempt to maintain the language as stable as possible leads us to another problem. So, how not to get too much technical depth around that? And in order to avoid all of that, basically Java has decided to go in a smoother direction in terms of multi-year transparent process of deliberate removal of features from the language and evolution in general. So it's worth to mention that despite some other languages which have done a lot of breaking changes through their history and broke the compatibility, requiring some to apply some revolutionary changes, Java decides to go in a bit different direction and allow us to actually maintain our applications workable as long as it's possible, still removing some features from the language. But why exactly we do this? So any subtraction from the language is the actual design signal. And these signals sent us by removal of features which exist, or, which is also important, rejection of some enhancements which are suggested by the community, are basically important things which language says to us. So this can be security posture. For example, features removed from the language might actually lead us to some security flaws. So it's important to avoid this. Again, this is about the performance philosophy. So rejections of some proposals or some removal of some features basically might be caused by potential compromise in the runtime efficiency. Also, it's important to note that there are some excessive maintenance burden, which basically should be avoided in order to allow the language to evolve and to evolve faster. As you can see, the language has started to evolve faster recently, and it's important to avoid all excessive stuff in case if maintainability of it actually doesn't bring too much benefit. Again, developer productivity is the one of the important values. So basically, the balance between complexity and benefits of some features actually leads us to leaving the most important and the most useful ones in case if we have different options on that. As you understand, definitely there are a lot of ways how we can write the similar code in the most of cases, and some tools just are not so effective in comparison with their complexity. And finally, ecosystem boundaries. So sometimes we need to understand that this particular feature is not necessary, even not for the 99% of the users of the language, but even in case if it's not in use for the majority of the developers, possibly this might become the third party solution, and this should be actually removed from the language for the sake of development as a separate product. This is also important, and this is also the way how some features have grown. So after discussing this, let's say, background, these signals, let's see some particular examples of how exactly this happened, why exactly this happened, and which alternatives have been introduced in the language. So the chapter one, what we actually removed from the platform. So what has been removed from the Java features? Let's begin from something very simple and possibly well known. And actually, the fun fact is that this feature is not yet removed. So basically, the object finalize method. As you can understand from this notation, and as you might probably know, this is the alternative option how to clean up the resources with the non-memory related resources after their usage when we should remove the object from the memory. So basically, this functionality has the good intention to allow us to close everything, to correctly, properly handle everything before stopping the system, before removing some project from memory. So this is the vital part of the memory management. But still, this particular feature is no longer in use because actually the rationale for the removal of this feature were first, performance issues. I would even switch the order and first focus on the unpredictable behavior because this is important to understand that we do not guarantee when exactly the finalize will be executed. And returning back to the step number one, performance issues, we also can't guarantee for how long this particular method will be executed, how much memory it will require, how much GC life cycles it will actually go through. And this definitely brings additional pressure to the system, sometimes not predictable pressure, and also, definitely some design flaws and even security flaws have become the reasoning for removal of that because we still can have the partially instantiated objects, partially removed objects. We can also bring some additional complex, insecure logic, which might be part of the finalized method execution, which potentially might lead us to a lot of unpredictable issues. While trying just while aiming just simply to clean up all the unused resources. So, as you can see, the decommissioning timeline. This is again about the long-going story, and not the longest one which we will see today. But Java 9 has become the first version where the initial deprecation of the feature has been announced. Then in Java 18, we deprecate, so the feature has been deprecated for removal. So this means that this, based on the JAP 421, this particular feature will be definitely removed from the language. And we're still waiting when exactly it will be removed. Timeline not yet finalized because so another side of any removal is that this might be a part of some legacy code which still might be in use, and the language should guarantee as smooth transition to the newer versions as possible. So removal of this mechanism is not so straightforward task. But in case if we would like to consider alternatives, definitely the simplest one and the easiest one for now is just to use the try with resources. One of the best features in terms of the managing of this stuff related to closing some resources when we just can define the resource which is auto-closable and guarantee that it will be handled properly, it will be automatically closed. We do not need to think about that, almost definitely. So there are some cases. But anyway, this is like the simplest solution which we can find to manage the resources in case we would like to avoid any stale, obsolete technologies. And an interesting alternative I find for myself, actually, I haven't applied this feature. Guys, would like to hear from you from the chat whether you have had experience, the real production experience with this. So, have you used the Cleaner API? Because basically this is even more powerful toolset, again built around the ability to register and remember resources which should be then proceeded with the cleanup of them. So basically what we can do, we can define this cleaner which we would like to then use as the register. Basically, I saw some recommendations to define it like even not the on the per class basis, but sometimes per library basis. And basically, the objects which we need to proceed removal with are become available for the cleaner when they are like have the phantom references only. And in case if we need to clean up the memory, we actually execute some code which basically is also just a regular runnable, where we can define some state and the resource which we would like to release. So actually, yeah, again, this functionality is a bit more complex, but a bit more powerful. Still, there are some issues which are similar to what we might meet with the finalize, but this definitely safer and this definitely much more manageable in terms of how exactly and when exactly we could expect the resources to be released. So, about we will talk about the major outcomes from the removal of the products later. Let's jump to the next stack set of methods. Basically, the thread control methods are also well known across the Java language since quite a while. And the interesting fact is that some of these methods have been removed, or at least it's better to say deprecated, for quite a while. So, as you can see in the decommissioning timeline, some of the methods have been deprecated since Java 1.2 in 1998. And they have gone through the long path before being finally removed somehow from the language, at least some of them. And actually, I would like to point out the rationale for removal, especially for some of these methods, like the destroy method. Basically, in case if we take a look at the definition of this method, it hasn't never had like it has never implemented. So basically, it throws an error instead of just being implemented. It's possible to override it, but definitely this didn't make sense originally, so that's why it has been deprecated also almost at the very beginning of the language history, and then has been finally removed in Java 11. So at least some of these methods have been removed. Again, in case if we're talking about the thread control methods, it's also important to add some points on other rationale for removal, like safety issues and deadlock risks. In case if we take a look at the example, this is the clear a view of how exactly this might be dangerous. So we can have the corrupted state of our objects, of in general, of the state of our particular runtime. So it's important that we should also manage and thoroughly orchestrate the ordering of methods, which we call like suspend and resume, and guarantee that the ordering is always correct and and all of that, which is also important and should be taken into account while operating such, let's say, low-level functionality. So that's why all of that methods, earlier or later, have been marked as deprecated. Some of them have already been removed. For some of them, we are still waiting for that. And in case if we are talking about the alternatives, definitely, like, instead of just stopping, we can try to interrupt the thread and instead to try to handle the interrupted exceptions and do this properly in order to stop work as safe as possible, giving the GVM the chance to stop everything and to do this properly in the proper way, proper direction. And in case if it's possible for us and if there are no specific concerns, definitely it's better not to use the low-level constructions and consider usage of some modern ways with the executors, with other synchronization toolset, as well as the thread toolset, which has grown in the language for a while, and which actually is rich in terms of any options of management of how the threads should be interconnected with each other, how they should react, how they should work in parallel, and actually have access to the resources. So a lot of stuff is already a part of the language, and it's not necessary to dig into the lower levels to manage this properly. So you can consider the Java util concurrent so library abilities for that. Definitely, this is all of that are well-known facts. So let's jump further to possibly less well-known toolset. So it's worth to mention that later we will talk about the toolset which we've already mentioned during our intro, so the applets, and actually. In addition to the benefits, they have brought a lot of insecure code which could be executed on the machines of users, together with some additional technologies which also had such abilities, Java Web Start, as far as I remember. So basically, in order to avoid the direct access to some resources which might be unsafe, like for example, we could have access to some I don't know etc passwd functionality to manage the permissions of the users in the operational system. This particular security manager library introduced in Java aimed to allow to set up the permissions within the language, within the library, to expose only some particular functionality for particular permissions, and to allow to have the access to file system, access to particular files, to execution of particular methods and classes and all of that stuff, creating kind of a sandbox which might become the safer environment to run in some insecure code. But unfortunately, or fortunately, can't say for sure. The history actually will gives us a chance to understand it better later, possibly, or we can at least say right now that basically this functionality has been removed. So the rationale for removal is that this security manager was not so actively adopted. Definitely, the complexity of maintaining all of that permission stuff as a part of internals of your libraries would bring high maintenance cost, and there are a lot of better architectural approaches and framework options which could provide us with ability to do this. And there are a lot of modern options of how we could manage the security and the levels of access to different functionality. So in case if we're talking about the decommissioning timeline, basically This feature was permanently disabled in one of the latest versions of Java. And again, we are talking about the long way forward, at least several years. So we have the deprecation for removal, then warning phase, where we see the warning while using some features and when the feature is enabled in runtime. And only after that, some permanently disabled scenario, and the future releases actually imply the API removal. So we're still waiting for them again. And this is important to understand that all these warnings we can see during the runtime phase are actually important, and we should pay special attention to them to understand which exact functionality libraries use, and we possibly might need to avoid in future. As for the modern alternatives, definitely in case of managing the, if we're talking about management of access to some particular packages and execution of some methods, modular system introduced for that purpose would work perfectly. There are some also not so, like, let's say, recommended, but still potentially feasible options in terms of the API interception with bytecode manipulation. Still, this might be an option in case if you really need and you have strong opinion that you need some management of the lower level resources and components. And definitely, the sandboxing around the code you execute can now be built in a lot of layers around the JVM, around the execution of the code. So basically, we can do this by means of having our containerization. So virtual machines, we can have some particular setups of execution for some compute resources within some clouds, where we can also guarantee some kind of security and different level of access. And we also have kind of prepared sandboxes in case if we're talking about serverless cloud computing. So we have a lot of layers of this sandboxing we can build around our code rather than integrating it deeper into the language itself. So that's why I would say that this feature basically can be easily replaced on a different set of levels based on your particular goals. This one is actually kind of interesting in its own way, because this is about the protocols of interconnection and communication between different services. And the RMI protocol itself and the RMI as part of the language is still alive. It's important to understand that we are not talking about the overall unavailability of this remote way of communication between the services. But there was a very, very specific way and very specific scenario, which is named RMI activation, where we could remotely activate some kind of procedure on this server without like having it, let's say, waiting for us, but having kind of a proxy which could tag it, etc., etc. Kind of complicated stuff. And basically, this completely explains the rationale for removal. This feature was introduced but haven't got too much community support. So the traditional RMI communication with the just description of the interface of server and client and methods stubs between them were much simpler and better to be easier to be understood. And again, obsolescence. So we do not need this feature anymore, taking into account a huge variety of different protocols for communication, different approaches, architectural solutions, which could help us to communicate between the services. So, like gRPC, REST, like the modern ways of communications, which will be touched during other talks today. So, the MCP protocol for the communication between AI agent and third parties. So again, we have quite a lot of specific ways of communication which might be clearer to understand, which could have their own goal, which could be clearly defined with the clear protocol of how exactly they are connected, with the more secure approaches of how they are connected. So that's why this particular functionality, the activation part of the RMI library, has been actually removed in Java 17. And as you can see, yeah, definitely, I will not touch too much this like the modern alternative in the REST API with Spring Boot or something like gRPC or something. Again, we still have even the standard RMI in case if we need to communicate between the so services, and we can organize the communication in terms of calling the remote procedure on server from our client. This part of the library is still alive and it still works on the newer versions of Java. Can say for sure for how long, because again, this is about some potential security flaws. This is again about the complex maintainability of this, let's say, quite old protocols of communication. But still, this is the part which is at least clear in terms of how to use it, why to use it, and why exactly it's implemented that way. And it's easy to understand in comparison with this like more complex IRMA activation approach. No, sure. So this is the JavaScript engine, and this is the combination of different languages. As you may probably remember, this is the way how we could try to execute some JavaScript code within our, let's say, so on the engine, which is a part of our Java code. Basically, definitely, it was the great first step, or one of the first steps, let's say, because this definitely was not the first one, in that direction of combination between the different languages and the execution of them. But yep, some maintenance challenges and better alternatives like GraalVM with, for example, support of something similar, basically have replaced this engine. So that's why it's already been removed. But again, we are talking about the long history of removal. Even such, let's say, niche feature in some direction might be explained. So might have the long history, which can be explained by attempt to support some maintainability for as long as possible. So basically, we have the removal of this feature only in 2020, but it was originally deprecated for removal 2 years before. And actually, it was in general alive for just 6 years, which also tells us interesting story about not all the new features, or almost new, or kind of fresh features are in active use, which are in active, which are not in active use. It's better to say. Basically, will continue stay with the language for a long time. This is also the important. So the dynamic of how a language removes the features and grows, and it's basically might be expected that some newer features might be removed faster in case if they have better alternatives, or in case if they are not in active use by the community, they do not have active support from the community. Still, this is the separate project which can be used as standalone dependency. And we definitely have the better alternative in terms of GraalVM, which also can do something similar and much, much, much more, which is important. And again, we have alternatives in terms of external JavaScript engines, which we could consider as an option to be run as a part of our setup. So basically, quite a lot of alternatives, a separate product which is still available in case if we would like to experiment around it. This is the current state of how we could replace the Nashorn. This is about the quite an old and even rarer stuff. This particular compression toolset, as well as compression protocol, PAC 200, is actually a part of how exactly these our products can be packed. But its complexity and the better alternatives in terms of the compression protocols have actually led to the deprecation for removal and then to removal of this feature from the language. The important fact here is that this is not just about some kind of particular I don't know, piece of code we write, but this is about how our tools are packed. We have the modern, better alternatives. Here is the overall example. Here are the important part of it. Gzip as the packing protocol works completely right, and we have the ability to create optimized runtime images using JLink. So definitely this support of such kind of old tool set, which is too specific from the language for the language, might even break some kind of initial architecture design ideas of the language, like write once run anywhere. This is important to try to get rid of such features in case if they are not in active global use. Corba is the communicational protocol again, and some Java EE modules. This is the interesting example of how some features have been deprecated, removed, but not like removed in terms of full cleanup from anywhere, let's say. So we still have the alternatives. We still have the third-party products and projects supporting similar functionality. So we have the Jakarta project, which supports these features, which actually were a part of Java EE, and this cleanup of the language from the features which have been like combined together in some point of time but haven't been necessary for the core functionality of the language. It's also important stuff uh, to be considered to be like split from the language, to be removed from the language, but distinguished from it, and still staying available as separate projects in case if there is still the niche where they are necessary. And Applet API, finally we reached it out. The earlier times of web development actually were full of different applets and as you may probably remember, Adobe Flash stuff. So basically together with these amazing features which might be animated, interactive, and might bring a lot of benefits in terms of executing some code on the client, actually, they also brought a lot of security concerns. They were complicated in terms of support, so the browser vendors have decided to avoid all of that stuff. Definitely, it have become obsolete because we have quite a lot of modern technologies which might work better, safer, and even the development of the key web component, not the components, this is not the right term, but key web technologies, let's say. The HTML, CSS, JavaScript is a language. Basically, development of them have brought all of that stuff to being absolutely unnecessary and even dangerous in comparison with the better modern solutions. So that's why, unfortunately or fortunately, we're waiting for the applet API to be removed in the next version of Java. And actually, we do have the better alternatives, definitely. So we still can maintain, for example, some backend stuff computation by means of the traditional communication protocols and approaches like REST API. We can use JavaFX for some particular components. We can just combine our knowledge of Java while writing the backend and writing the front end on the better suitable technologies from different stack. So this is the route which removed the complicated, insecure part of the language, which was the product of its time, definitely, and was necessary at the moment. But currently, it's already obsolete. And a brief overview of some removed tools and components. So basically, Jihad. You have probably seen some notes on that tool. So basically, this is the heap analysis tool for viewing heap dumps. And this tool was removed because of the better, superior alternatives. All of that stuff with the so the feature was experimented. It was not actively supported. It has become out of date, and definitely, in case if you use, for example, Eclipse MAT for the heap dump analysis at least once, you can understand how well it works and how well it covers this area. So you might not need the other tool set in case if you would like not just get the particular dump information, but to have this like comprehensive report with some ideas on where exactly you might have the bottlenecks and what exactly your heap dump consists of. Again, Java H tool, which is native header generation tool. It was simply replaced by the Java C with the particular key. So it was just removed as a standalone tool, but has become a part of another tool for the sake of simplicity and clearer state of the language. And it's no longer needed as a separate tool, actually. And as I've already mentioned today, so Solaris and Sparsi, so the parts of the architecture and platform for the operational system around Java have also become obsolete because Oracle no longer developing this tool set. High maintenance cost of it can be one of the explanations and rationale for removal. And definitely this burden and obsolete functionality maintenance cost would block new feature development like Valhalla, Loom, Panama, etc. So that's why it's been decided just to remove these features for the sake of saving time and resources for the more effective and useful ones. And finally, chapter 2. Still, despite the fact that some features are introduced based on the JEPs, and a lot of the most of features are introduced as JEPs, as suggestions to improve the language, some of them are definitely withdrawn, rejected, and sometimes they still stay in the candidate state for a long time and become a part of the of another features. It's important to understand why exactly this happens as well, and why this withdrawal and removal on the earlier stages is also important. So let's consider several examples. Enhanced enums. So basically, this is the suggestion to consider having these enums as functionality supporting so some specific syntax like generification or ability to for methods to be introduced only for some individual specific constants. This is basically huge, interesting, powerful toolset which could become a part of the language, but it also has brought a lot of complexity, a lot of generic interaction problems of how this should be interpreted in the language, of how this should be maintained in terms of compatibility with other language features. There were some well-formedness issues, and definitely a lot of complexity without solution. So the decommissioning timeline is interesting here. So after the proposal of JAP, we can see that there was a phase of initial resistance where the features introduced described in this chap were improved and clarified, and there were a lot of communication on how this still might become a part of the language. But later, after prototyping revealed, so it actually revealed not just the benefits but also some fundamental problems. And finally, 3 years later, this job has been formally withdrawn. So we haven't got quite a lot of interesting features which might become the forgotten future of the language and alternative way of the development of the enums as structures. But also, we haven't got a lot of complexity and problems which might be brought together with this feature. Next one is string templates. This is kind of clear feature in terms of understanding of reasoning. So basically, we could have some kind of basic syntax with the word like str or something. After this, we could describe the template with some placeholders, and then these placeholders could be used. So basically, we have the similar syntax in Python with f strings, with Scala with s strings. So we have quite a lot of options of how we could do this in different languages. And there was a suggestion to use some kind of alternative in Java and to introduce it, for example, to have some kind of template processors which could help us with some specific cases, like building some SQL queries, for example, say from SQL injection. Also, like for the JSON object structures, etc. But there were quite a lot of debates around how exactly this should look like. Again, the design complexity and some fundamental reevaluation of this feature led to the following timeline, which is interesting. We had this feature as the first preview in Java 21. Again, we had this as the second preview in Java 22. So basically, this functionality was a part of the language in previous stage, but still. And we have this like preview, third preview proposed for Java 23. And finally, before the Java 23 finalization, so before the actual release of the language, unfortunately or fortunately, again, this proposal was finally withdrawn. One more proposal, which might actually feel similar to what we have got finally in the language, and this is absolutely true. So the raw string literals were the backtick syntax was applied in order to have this like specific string which might be multi-lined, which might not require some like pluses with all of that movement between strings or something. So it might look a bit simpler than what we have got in the language earlier. But there are a lot of different issues in terms of the like overall design concerns with this approach. Basically, the better alternative was finally found and introduced in the language. So the actual text blocks, which you, as you can see, look a bit like simpler and clearer, but still might need to be escaped in some certain context. And this raw string literals job was finally superseded by the text blocks. And finally, the long story, which is still in progress again. So the feature, or it's better to say a set of features, which stays in kind of limbo, which is currently in the candidate state for a long time already. Basically, these are a lot of different proposed improvements in terms of how lambdas are defined in Java. For example, one of the options was the having the underscore for unused parameters. So there also an option to allow lambda parameters to shadow enclosing scope variables. Like, for example, in case if you define the key variable with some value before your lambda, and for example, within the lambda, you define the expression where you use this keyword key again. So definitely, this is not allowed in the actual language, but you could. So there was an idea to consider option of how this could be allowed and lead to more flexible variable naming. So basically, this is interesting that this particular job has become the groundwork for different other improvements already introduced and incorporated into other releases. So the remained features are still under consideration. They might become a part of the language, they might not become a part of it. We will see. So, finally, the lessons learned from my long story today. The key takeaways. Basically, removal of features like finalization, threat control methods, security management actually demonstrates commitment of the language to eliminating unsafe patterns, even at the cost of backward compatibility, which, as we have told a lot before, is one of the key values of the language. Again, features like AirMy activation packed to 100 Nashorn Corba were removed primarily due to high cost of maintenance relative to actual usage. So, in order to focus on modern features, the language decides to avoid and get rid of the obsolete ones. Again, the platform modernization, the global platform modernization, not only related to Java, actually can be seen through the removal of applets, some legacy tools, platform specific ports. So basically, this shows its Java evolution from its roots to a modern streamlined platform. And actually, yeah, definitely the communication and the actual ability to impact on how exactly the language grows is shown through the preview process and how some features have been withdrawn. Preview process works and matters. So that's why the community feedback is necessary and important. Actually, I sometimes I'm really sad why exactly the Java community, in terms of the overall users of Java, our overall Java developers community, might not be so active. Like, for example, the community of some web tool set, where they communicate a lot directly on some features on like with the browser vendors, with the authors of the languages, to make them better. And I think this is something which possibly Java engineers might miss sometime. And it's important to take part in this conversation and to give your feedback. And backward compatibility balance. So, as you can see, the most of the processes I explained and showed today were long going. So, 5, 10 years, even more of careful. So, this shows careful balance between the progress and stability, giving us as developers ample time to migrate. And we shouldn't waste it, taking into account our overall tension to actually in intention to stay with some version of Java as long as possible, because we need to develop new features rather than spend some time on migration. In terms of migration, some possible tips, tricks, migration strategies which you could consider just as an ideas. So, if we're talking about some potentially removed features, in order to migrate safely, we could monitor some deprecation warning. We could use some tools like GDepR scan, which is a part of the JDK, to identify some deprecated API usages. We could test some features, trying to disable them and see how exactly our application, our runtime will behave. Plan some migrations during major version upgrades, and leverage automated refactoring tools where available. Taking into account the development of AI technologies, this is the wide range of options here, how exactly this should be automated and simplified, and how exactly we could transform our code to the newer version at the lower cost. And as for rejected features, in case if you see some interesting job and you would like to experiment around that, don't depend on preview features in production. Definitely, by any means, do not do this. In case if you experiment on some features, with some features, please provide feedback during these preview periods using the appropriate channels, because this is important to actually see the response from the community in order to move either forward or backward with such kind of jobs. Again, be prepared for the feature changes or withdrawals in case if you try to adopt some new features which haven't been globally fully officially included into the language. And follow JEP status changes on OpenJDK website in case if you're interested in where exactly the language actually moves forward. And finally, some ideas on best practices for long-term Java development. Definitely stay current. At least try to regularly update to the supported Java versions. It's great that currently the modern environment stimulates us to move forward. Like, for example, some end of support of the language features or some kind of cloud infrastructure which we might utilize for running our environment and which requires us to move forward with the versions actually push us in the right direction, in the direction of the staying current. Again, monitor deprecations, pay attention to annotations, warnings, and related stuff. Test early. So use early access builds to identify some potential issues which might be caused by deprecation of some features and potential removal of them. Uh, Avoid internal APIs and experimental features. Sometimes you might feel the strong desire to use this particular internal function which fully suits your the current use case, but this might lead to the fact that it might be changed unexpectedly and in the unexpected moment in the newer versions of Java. So you need to take this into account while deciding on which exact APIs to use. In case if you have this great opportunity, participate in JEP discussions for preview features and give your feedback on any concerns or any benefits you see in some features. Definitely plan for you need to have a plan for change. You need to think about awareness, so how exactly these particular features will continue to work in case if other features are removed, and if you use something which seems to become obsolete and there are some plans for deprecation or some discussions around deprecation of that. And the most controversial point, but in case if you do this, good for you. I am absolutely happy that such people exist. If this is the case, track which JDK features, like major features, possibly obsolete, deprecated features, which might be removed, your code relies on, or at least take this into account while working on the future improvements and future development of your product. And basically, it's worth to mention that a lot of principles around them that works not only for the language we use, but also to the tool we implement and we create, and to the legacy code we actually develop, because any code which has already been developed can be considered as legacy. So we should also pay attention to try to do deprecation process of our features as smooth as possible and to basically be able to support these key values which language actually studies us to follow. So more or less that's it from my side, and I would be happy to hear the questions from you guys, but I see that I don't have too much time for that.
Yeah, first of all, thank you very much. Very great talk and great overview on all features. And it's a pleasure for me to read in the comments that people see the features they were working with. Like one comment from Yuri, like feeling so nostalgic about those features. For some reasons, I've been working with them since 2012. It's like quite a while, quite a while.
That's cool.
So yeah, maybe just a comment from my side. Is that, guys, like, just a bit of experience. uh, I recently migrated several projects from one Java version to another, and it's really easy to do so. It's like it's really easy. You basically just switch version. Not a lot of things you need to change. more problems when you need to migrate framework. So migration of Spring, like from 2.7 to 3.1, this is like hard. Migration of Java, it's really easy. So don't wait. So it's really nice. Java 25 was released like 2 months ago. So yeah, Java 21, it's definitely your choice now. You can even
Yep,
do
yep, yep.
20
Not
25 if you
Java
want.
25. At least for now, at least for several months.
Yeah,
So more because
not
yeah. Anyway, we need to wait this version to stabilize a bit.
well, not about a version, but more about frameworks. So not all
Yep,
frameworks can
yep, yep,
support
yep, yep,
that.
yep.
Your
Definitely.
project can use some library which not support that. So yeah, we don't have a lot of time. We have one question. I will reformulate it a bit as there already an answer from Maxim. So what do you think about unsafe, which was marked as deprecated in Java? And so what is your opinion about this library? Because it's marked to deprecation for quite a while ago. I think like around 5 years, maybe more, but it's still somewhere there. So what do you think about that?
Actually, I think that this is again about the key principles I've explained and shared with you guys today. So, definitely the functionality was marked, which was marked as deprecated, in case if it has become a vital part of the language and the libraries we use and the legacy code we implemented. It's not so easy to fully remove it. So that's why possibly it stays with us for a long time despite of the obstacles, despite of the issues it might bring, because the stability of the language is also important part of the overall framework. So that's why I do believe that if feature is marked as deprecated, it should be finally removed from the language because it has already become obsolete and we should avoid it. But anyway, this might require some time finally to get rid of it. And this is okay, but we should keep in mind that in case a feature is marked as deprecated, it doesn't seem to be a good idea to actually introduce it in new functionality. And in turn, it might be a good idea to try to find the better alternatives in terms of overall architecture of the products we develop.
Yeah, great. So, Tanya, thank you very much. Great talk. And thank you very much for being part of Java On and being part of Java On org team. Thank you very much.
Thank you to be here. So thank you guys, and have a lot of fun with further talks.
Thank you.